ahead.
Yeah. So let me introduce Radoslav Stankov. Um, he will talk about React Native at product end. So he has 80 years of experience, and he's also organizer of React Not-Conf conference and React Sofia meetup. That's awesome. Please give us more information about you if I miss something, and then the stage is yours. You can continue, and I'm here for any help at any time.
Okay, cool. Hello, everybody. Sorry of being a bit late. There was misunderstanding. So I'm going to talk about React Native. And yeah, hi, my name is Radoslav Stankov. You can find me on the internet as R Stankov pretty much everywhere. I'm head of engineering at Product Hunt, and today I'm going to talk about the React Native architecture of our application. But in order for us to understand an architecture of an app, we have to understand the context and what's the situation this app is, what's requirement, and so on. So the app I'm going to talk about today is our Product Hunt mobile app. So Product Hunt, for people who don't know, is a website where we feature the hot new releases every day. And I have given a lot of talks about our front end and back end architecture, which you can check out. But again, today I'm going to talk about our mobile app, which we re-architectured last year and released in January. And when we were thinking about building this new application, we had two choices because we wanted to build the application from the ground up. We had to decide between like two technologies, which were like just going native or just go React Native. So what we decided to do is we started analyzing our options. So 2 years ago, we had a really bad experience with React Native, and we were a bit hesitant to use it, but it had improved quite a bit with our test. On the other side, we only had 2 developers who had some experience with Swift, not very recent one actually, and 0 developers with Android experience. And our backend is all about GraphQL, and the Apollo for Swift isn't very good. It's decent, but not as good as the React one. And our team already knew how to solve kind of all the problems we had in React and React Apollo. Also, we wanted to experiment a bit more in the UI part. So we needed to do a bit of UI iteration and experiments, which is also something not very good with Swift. And also we needed Android as well. So early in 2020, we made another app called Your Stack and another called StackCamp, just like an experiment for various products we had. And one of them was Swift and the other was React Native, and we were able to compare. So in the end, we decided to go to React Native, I mean, as you get from this talk. And the tech stack we decided to choose is React, GraphQL, Apollo, TypeScript, Jest, Prettier, and Fastlane. And this is, again, most of the time when we get our stuff from React is just we get to like this state where we have to build all the stuff ourselves. And if we don't think early enough, we can stuck in a corner and we cannot have a way to get out. And we wanted to move fast and have breakfast nicely and calmly and wanted to move. So when we decided to architect the app, we were thinking around our 4 architectural principles. The first and the most important one is make the common operations easy. Like every time you do something, it should be very easy. We should have really good code organization. The other one is to isolate dependencies so we can upgrade easily from things to things. And the other one is have extensibility and usability in the things we do, because we're a very small team and we should be able to reuse our code. The way I'm thinking about the architecture is the architecture has like 3 pieces, and they are support, components, and screens. And I look at this as a pyramid, or like this, you get the support, which drives the components, and the components are grouped into screens. And when you open our application, this is our component directory structure. And this is basically, if we color code it, you see this, the blue one is the support, the green one is the component, and the red one is the pages. And as I mentioned, again, talk is cheap, and I want to show you the code. Here is, again, let's start with the screens. So for the screens, all the screens, we decided to use React Navigation. And this is how the main screen looks like. So since our application is basically very similar to the web application, where from almost every screen we can jump to another screen, like from a post you can jump to a pro, to a user you can go back to another post, you can see galleries, collection. We just have a main navigation stack with all the components, and we have all the screens exported in the central place called screen. And we just say, okay, the initial route is the home name screen, and it's in the header mode, and we have the screen definitions that we just inline from the screen component. The screen itself is just, okay, exported the whole screen files. Each screen is in the root of the directory screens. There is like screen directory for every screen, and every screen has like some private components, and those are components needed only for this page and not everywhere else. A GraphQL query, an index file, and every screen is just like a state machine, not just like it is a state machine. So it has some layout depending how we want to display it. When the screen is initially loaded, it gets to loaded state. Sometimes it can move to an error state where there is a server error, something is not found, there is authorization, authentication, and other various errors. Or we go to the loaded state where we just render. And if you notice, this whole thing has to be standardized for every screen we have. The only part that's kind of unique is the render. So what we created is something very similar to what we have on the web, and something very similar to how was dealt with the old iOS native days with view controller. So we have this function called create screen, which has various options about what our screen is about. Like, for example, it says, okay, this is the name of the screen. This is what GraphQL query needs. This is the variables for the query. This is the component it renders. The type of the screen, we have 3 types of screens. What's the title? What's the background? Is the safe area or not included? So having this allows us to very easily make the common task of building the screen really fast. And this is how the home screen looks like, and it's basically pretty much the same thing. We just have like a cursor now, we have the layout, we have the data, and we have all of that. The other core pillar of the architecture is GraphQL. So the way this works is we have the Rails in the backend, which generates GraphQL, which is consumed by Apollo, and we use TypeScript to have a type-safe schema. So there is this tool called Apollo CodeGen, which allows us to get fragments and to actually split our GraphQL queries into small fragments. And when we have a fragment for a component, so for example, the profile avatar component has the name, the kind, the image ID, and from it will generate a type that we can use in our component, so we actually know that the component works the way it's expected. And when we export it, everything goes through it, and it works fine. So when we combine those fragments and those components, they move up the tree, then it goes to the main query. So the idea here is what we have is the query which combines multiple fragments. And if you think about it, this mimics exactly our directories, our tree structure of the React component. So we have screen with various components, and from this we generate type-safe query that we know can be executed, and we get from the other side types. And for me, this is kind of a magic. It makes the problem with data fetching, what's needed for the data, what's not, basically not an issue. Another thing we do around the screens is the routes. So this is a pattern we used in the web a lot, and it was very useful for them from here as well, where we say, okay, this is the routes, and the routes are just functions that generate descriptor how to get to a screen. And we have those helper functions to help us do that. So I can say routes back, this would go back. I will have routes login, and this would do a login screen. And I have this component where I can say navigate, and I can say on press, navigate to product with ID 5. And this is very common, so common that we actually integrated it into our code button component, where you can say, have a button that links to this product. And this lets me down the next level of abstraction, the component themselves. So the components themselves, for us, the things that live in component folder have the very simple rule is that components there should be used at least in 2 screens, in 2 places. So the components follow very similar rules as the screens in terms of they're all directories. We only think that the root directory of components is the public folder, and everything else is considered private. And they have their own fragment, mutation, index, and so on. And we have components like text, which we predefine the text, so our app is consistent. We also have something called spacings, which is very useful for spacing components. Like we can say the size, the component, the color, the bold, and the true. We also, again, as every app needs, we have a button, and as a foundational component, as I mentioned before, we have the button, which is button 2, and we have the profile. Also, you can say button on press and give it a function. And the cool trick here is if the function returns a promise, the button cannot be tapped until this promise resolves. We also give a couple of other helpers like confirm. Like when you click it, we show like a pop-up to confirm. Also, for certain actions, they can only be performed by people who are logged in. So we should say require login true. That means that the user should be logged in to perform this action. And for button, we also integrate the button component into GraphQL. So where you can say this button executes this GraphQL mutation. This is the mutation input. And when the mutation is done successfully, execute this. And this functionality makes it very easy to add buttons with various features. The other thing we have is we use button as package components. Like, for example, we have a button which is a text. We have a button which is just an icon. We have a button that's solid. We have a button that's outline. So all the buttons are very consistent throughout the app. The other things we do is we abstracted the Yoga Flex layout from we extracted the Yoga Flex layout, and now we have this component called Flex, which abstracts the CSS. The CSS creates style sheet. We have React Native. Like, the nice things we do is we almost don't have custom styles now on our main component. So, for example, here I can say there is a flex row, there is a flex column, and I can also have this flex is expanding. There's this flex grid. This is flex text. And the idea here is we group the components into domain, styling, and utility ways. So if we look at this screen here, we can focus on its single component, which is this post item. And the post item itself has a vote button, which is a domain component, which uses a style guide component, which is called button. But also the vote button is inside a post item. And if we look at the screen is just built with almost zero customization of styling, because this is a screen. It uses something which we call dismissible keyboard, which is basically if you have a keyboard and you tap on the screen, the keyboard closes. It uses a post item, which is a domain component, and the post item itself is just a flex column, which has a role, and this row has a vote button, and the button has a button, and the button actually is flex column with icon and text. So you see how those components propagate. And this kind of sounds like atomic design. We don't officially use atomic design. For us, we just have generic components and domain components. And this leads me to the end of the thing, and this is the support. And the support is basically just the utilities we have in our application. It lives in the utils folder. We also separate the utils and hooks. The reason to do this is because hooks have special rules, how they're named and how they're called and what are their properties. So, and with the other util we have is styles, and I'm going to talk a bit about styles right now. So styles have basically we need to one of the cool things with styles is we have this module for spacing, and the module for spacing is that we have the ability for each of our core components to say, okay, margin left, medium, large, and so on. Or we can say the padding. And this is something we don't do on the web. Because of the web, we have something like a flex component. We just have a gap, and this gap is automatic, and we don't have to think about it. But here we have to have this on the web. And the idea here is we can just say we have this module called spacing where we have predefined all the margin, padding, and all of those. And from here, we just override the style. So this is, for example, a component that uses this spacing schema. Another cool thing we wanted to have, and that's one of the other reasons we built, was we wanted to have support for dark mode. And for dark mode, we use a library called React Native Dynamic. And we wrapped it, we don't use this library directly, we wrapped it in our own plugin, which allows us to just say something like use color. So what we would do is we would say, okay, the background for this use color background, and depending on which color scheme the app is on and off, you use this color. And it's a nice way, for example, to use this. This is how this file looks like. You just have a hook which you get if you're in a dark mode. You say use colors, then it's a function that can just bypass the theme system, because we have a couple of widgets that are kind of the same. And yeah, this is how the whole app is combined, and basically how the thing works. And for a quick recap, one of the key takeaways is, again, we have everything powered by GraphQL, and the GraphQL starts from the bottom to the top, like our servers speak GraphQL as the API, and we built all the components on top of the GraphQL type safe schema. So we have type safety in everywhere, and we know what's going on. It's very easy to say what data you need. On the screens part, I think two cool takeaways are the create screen. I think it's a function that everybody should create for themselves. So they have an easy way to build new screens and separate the screens from the components. And the other thing is the screens helper, the ones which I mentioned, like with the routes, where you actually have a map of all the routes, and it's very easy to see what the app is about. On the component side, what I mentioned is we have the domain components, we have isolated dependencies, and we use a lot of directory as folders, like basically all our components are just folders. So yeah, thank you very much, and that's all for me. You can find the slides on my speaker deck. They're over here. And later today, in a couple of hours, I will be on a live QA session. So if you have any questions, you can just ask me. So yeah, see you on the live Q&A session. Thank you very much.
Thank you. Thank you very much. It was interesting. There's this kind of question to you until to the Q&A session. So almost 3 years ago, when I was working on React Native projects, in our product, we wanted to create web application and mobile application. And I suggested use all the functionality, like related to API calls, related to Redux stuff, create and store in a common place and use that as a SDK, and speed up the whole process of the development web application and the mobile application. Do you have any experience sharing common code between web application and mobile application?
So we actually, yeah, so the idea there is we don't share much. Most of the things we share are helpful utilities and things that should be a library which don't depend on the view layer. Like, for example, we have a number for format. We have a function that formats numbers. We have a function that handles reducers and some custom React logic. So those things are all in a separate place and they're fairly stable. We don't change them a lot. But for example, most of the things we reuse between the apps is patterns. Like, for example, the API for the button component on the web is very similar to the button component on the iOS stuff, but the implementations are totally different just because on the web, we need to have server-side rendering, the Apple account is passed via one way, and on the iOS, we can cheat a bit in a couple of ways. Or, for example, putting up a login dialog on the web is one thing, on the mobile is different. So I have found that the thing that makes sense to be shared are mostly like pure functions and utilities, and not so much like a business logic and UI elements. Also, the thing that helps us in our case is that all the logic is shared in the backend, in the GraphQL layer. Like, GraphQL kind of removes a lot of business logic from the front end and push it back to the backend.
Yeah, thanks for your answer. And one note, please leave your comments, your questions in the chat, so we will get back them soon in the Q&A session. Thank you, Radoslav. See you soon.
Yeah, bye-bye.
Bye.